Last time we studied about last time we studied about factorization. Now these are the things which we learned in the factorization. Just a quick recap. Now, these are the techniques by which you can factorize any given expression, which is in the expanded form already. One, by taking common, by using a process of common. Second, by using algebraic identities if the equation is a quadratic. The third one, a middle term breaking method. Now, these are the types of expressions we have. We will be deciding what kind of uh, equation or expression we have so that we can decide the technique accordingly. This was just for the general knowledge because we shall be encountering with all these kinds of expressions, and later on the same expressions will develop into equations, and then we shall be solving them. Case one is now there were different cases so that you can the cases were designed in such a way. I told you the cases so that by looking at the question you should be able to determine, like, out of the three techniques mentioned above, which particular technique you will be using. Now the case one is if you have two terms given in the question and if there is a positive sign between them, then you will straightway go for the common technique. Case two was if you have again two terms, but this time you have a negative sign between them. So the first priority would be that you will check if you can rewrite each term as a square of any particular number. Then you will apply a third identity, which was if you have a square minus b square as an expanded form, then you will be doing a plus b times a minus b. This is how the factors will look like. And if you are not able to rewrite each term as a square of something when you have a negative sign between them, then you will simply go for a common. Case three was if you have three terms and the three terms make up a quadratic expression, then you will go for a middle term breaking method or a completing square method. Now, what is a completing square method? This is what we are going to study today. Completing square method is basically you factorize by using first and the second algebraic identity. Okay, now, and the second thing was if the three terms are non-quadratic, like they do not make up a quadratic expression, then you will simply go for a common one. Case four was if you have four terms, then you take common by grouping. Now this process goes in two folds. You take common from the first two and then the last two, and then you take common one more time so that you can have factors. So we did other few examples the other day. I ask you to go through the worksheet, and wherever you find out the question of the two kinds, one was with the command word of factorize, the other one was simplify, having a single fraction in it, and then factorize that. I just saw one of the question. Okay, now just for the quick revision purpose, I'm going to do this question is for the purpose of the recap. Okay, now in the numerator, I have 4x squared minus 16x. This is what I have in the numerator. In order to simplify, I need factors in the numerator and the denominator so that I can simplify it, cancel the factors which can be cancelled out. So definitely we are going to factorize. So we are going to do turn by turn, first the numerator and then the denominator. Now, as you can see, you have two terms and you have a negative sign between them. So as I stated earlier, in the cases, whenever you have two terms and there is a negative sign between them, your first goal is to check if you can rewrite each of the term as a square of something. Now, if you check this 4 can be written as a square of 2 and x squared is already in the form of square. This 16 can be written as a square of 4. What about this x? Is this a square of any number? Can I write this x as a
No,
square of something?
no, no, sir.
No, no. So what I'm going, so basically, I cannot use the third identity over here. We were only able to use the third identity if and only if I am able to rewrite each term as a square of something. So if I cannot rewrite each term as a square of something, so basically I'm not going to use the third identity. What was the second step? You go for the common. So what is common in each of these? Now looking for the number, which is the largest number which can be divided on both the numbers here.
4.
4. And looking into the variables, so I have two x's here, one x here, so
X.
one x is common. So 4x is common, so I'm left with x minus 4. That's it. That's all. I'm done. So I cannot factorize this further. Okay, now moving towards the denominator part. The denominator is 2x squared plus 6x minus 56. Oh, luckily, we have a question of the kind which we were talking the other day. Now, you need two numbers. When multiplied, you should get what?
56.
No. This is the point which I
Sir, we
mentioned in the
need
last
to
lesson.
w- we need to multiply 56 with the 2.
Yeah, 56 times 2. Do not create this idea that this is the number which has to come here.
112.
Why do even students create this idea? Because many questions have 1 over here. So 56 times 1 will give you 56. So that is why students think that whatever number we have over here, that will come down here. No, that's not the case. So 56 times 2. What do we get?
112.
112. Okay, so we need two numbers. When multiplied, you should get 112. And the very two same numbers, when added or subtracted,
Subtracted.
yes, we get this idea from a sign of a constant number, which is a minus. So I'll be taking a difference of the two same numbers, which I'll be multiplying up there. And what should I get after taking a
Six.
difference of the two numbers?
6.
Yeah, with the sign, which is plus 6. Okay. Now, think of the two numbers. When multiplied, you should get 112, and when subtracted, you should get 6. Now, 112 is such a number which is not a very common multiple, which you see in the regular times tables. So what you can easily do is do the prime factorization of 112. So I'm going to do the prime factorization of 112, list down all the prime factors of it. Okay, now 2 times 5 is 10, and then 1 carried, so 2 times 6 is 12, 2 times 2 is 4, 8 is 16, 14, 7, and then 7 is a prime number, so 7 times 1. So I need two numbers. So how many numbers do I have here? 1, 2, 3, 4, 5. So that's not helping. So I'm going to make them I'm going to multiply the numbers and see, like, pull out a group of 2. So 2 times 2 times 2, the first 3 is 8, and 7 times 2 is 14. 14 times 8 is definitely 112, because these are the prime factors of 112. So when multiplied together, this will definitely give you 112. All you have to check is if the difference is 6. What is the difference of 14 and 8?
6.
Oh, yeah, that worked. So 8 and 14. So this was the easy way out in order to find out the two numbers. So 8 times 14 is 112. Now the difference of the very two same numbers will give you 6. So should I do 8 minus 14 to get 6, or 14 minus 6? So
14
14 minus
minus
6.
8.
Yes, because I need plus 6. That's good. So you're sorted here. You can erase the rough work, and you can continue with the question. So 14 minus 6. So 2x squared, you will be breaking down the middle term, which is 6s, as 14 minus 6, and then like this. Okay, now you have 4 terms. Now you move on to the case where you have 4 terms. Now you take common from the first 2 terms, 2x, what do you get? X plus 7. And then minus 6 is common from the second one. Now I'm taking a negative sign as common, which will change the sign of these two terms. Now the first one here is with the minus, the second one here is with the minus as well. So inside the brackets, they both will have a positive sign, because I took a minus sign as common.
Sir, you've written the wrong number. It's minus 8x.
Where? Okay, yeah. Thank you. It's 8. Thank you so much. This is 8. So x and 8 times what is 56? 7. Thank you. Okay. Now you take common from these, which is x plus 7. You're left with 2x minus 8. So the factors are x plus 7 into 2x minus 8. Is that all? Done?
Yes, sir.
Yes, sir.
No, look carefully. We can factorize it even further. Apparently, we have two factors, but one of them can be factorized even further.
Sir, 2x minus
2x
8.
minus 8.
Yes, how will I factorize that?
So by taking 2 as common.
Yes,
Yes,
sir.
I will take 2 as common from this one. So 2 is common from this one. So x plus 7 comes down as it is. So 2 is common from this one. So I'll be left with x minus 4. So this is how you factorize it completely. So in the numerator, you write it down 4x into x minus 4 over. In the denominator, you write down the factors of 2x squared plus 6x minus 56, which 2 into x plus 7 into x minus 4. Now you simplify it and you will see you are left with 2x over x plus 7. Got it?
Yes,
Yes,
sir.
sir.
So there is nothing new. Only question changes. The look of the question changes. Do not get scared of it. Okay? Just jump to the question. Put the rules in front of you. Apply the same rule. I did this question in front of you. This question was looking scary, but the no new rule was applied here. Everything like was exactly the same. All you have to do is you need to focus, put the rules in front of you, and then solve it. All right. Now today we are going to study how can we factorize by using a completing square method. Okay. All right.
Sir,
Now
can you repeat the name of the method, please?
here, completing square method.
Okay, sir. Thank you.
Okay. Now completing square method. Completing square is a process which is not only confined to factorize. Like you can use the completing square method in order to factorize, but you can use completing square method for some other purposes as well. But today, first of all, I'm going to teach you that what is actually a completing square method. Then we will move further and see where else we can use this particular method. Well, completing square, what do we actually mean by completing square? Completing square means whatever equation you have, ax squared plus bx plus c. Now, this is a quadratic equation. Now, whenever you remember this point, whenever you get a question in exam and the question asks you to factorize it, and under the command word you have a quadratic equation, straight away jump to the middle term breaking method. No other option. Middle term breaking method. So what did I just tell you? Whenever the examiner asks you to factorize and you have a quadratic expression, do not think of any other method. Simply jump to the middle term breaking method. But when the examiner bounds you to factorize by using a completing square method, then you are bound to use a completing square method in order to factorize that. Now, what is actually a completing square method? You rewrite, you transform the given expression into this particular format, and then once you have this format, then you obtain the required factors. Does this one look familiar to you?
Yes,
Yes, sir.
sir.
It's one of the identities.
Yes. So whatever expression you have, it can be anything, ax squared plus bx plus c. So whatever it is, you transform it. Do not change the question. Transforming means like 4 is same as 2 square. I have transformed the number 4 as 2 square. I haven't changed the number. 2 square is still 4. Okay. So I will not be changing anything. I will be only transforming. I'm not going to change the values of the given expression. So I will be transforming the given quadratic expression into this particular format, which was basically the expanded form of the first identity, because I know when we have the expanded form of the given when we have the expanded form like this, a squared plus 2ab plus b squared, the factors would always be a plus b whole square. Let me quickly show you the identities from the previous lesson, which was, I guess, in a lesson where we started factorization. There you go. There you have the factorization. We use the algebraic identities for the expansion purpose. So look, these were the factors on the left hand side. A plus b whole square is a factor. The expansion was like this. Now what we are going to do, we will be uh, transforming the given expression, which is definitely in the expanded form, into this particular format. Once I have this, I know the factors are a plus b whole square. Exactly in the same manner, either you are going to transform it according to the first algebraic identity or the second one. Like the second one has a negative sign with the 2. So it's the opposite of the algebraic identities which we studied the other day. So when you have a minus sign with the 2, then the factors look like a minus b the whole square. Okay, so you have an idea that what are we going to do today. Now I'm going to write down a question here. Just hold on a minute, please. Okay, now just a minute. I'm actually trying to make a perfect question. Okay, now this is a quadratic expression, which definitely you can factorize always by using a middle term breaking method, but this is not what we are dealing with for now. The examiner, just imagine the examiner is asking you to factorize this by using a completing square method. Now I'll be teaching you two things over here: completing square method and factorization simultaneously. So basically, I will be factorizing by using a completing square method. Okay, now this is how I'm going to do the complete. Now, what is actually completing the square means? Completing square means transforming the given quadratic expression into either of these two formats. Once you have this, you are good to go for the factors. Okay, now I'm going to transform each of the term. Now, first of all, I need to decide this one matches with which expression, the first one or the second one, like the expanded form of the identity. The first one or the second one? What do you think?
First one.
The first one, because I can clearly see all the signs are positive, and that was the only case in the expanded form of the first identity. So what you can do is write down the identity just for your help so that you don't go anywhere wrong. Just for your help. Now you know that you will be transforming the given expression, which is in black, to the model, which is in blue. Do not change the question, just transform it. Okay, now first of all, I need a whole square of something. So is 4 a square of something?
Yes, sir.
Yes, sir.
And
Two.
that is
Two.
2.
2. Excellent. And what about x? Yeah. So my question is, are these two actually equal?
Yes, sir.
Yes, sir.
Yes, because 2 square is going to be 4 and x square is going to be x square. So I haven't changed the question. I'm only transforming and trying to achieve the model. So I'm done with a square. So a is, what is a over here? I'm going to highlight it with the green. What is a over here?
2x.
Yeah, just the 2x, okay, not 2x whole square, okay. A is inside the square, which is 2x. That is the purpose of keeping the model in front of you. Okay, now plus, as I am trying to achieve this model, so in this particular model I have 2, so I'm going to put down 2. I need this 2 because that's the model which I am trying to transform into. Okay, and then I have A. What was A? I highlighted it in green. What was A?
2x whole square.
Just A, not A square,
2x, 2x.
just
2x.
2x. Okay, now B. Now you need to decide B here because you know these three things are being multiplied here. You do not want to put any random number over here. Whatever number you put here, make sure it gives you 36x. Like this whole thing should end up same as 36x. So
So,
what do
sir,
we
we'll
have
put
already?
9.
4 times 4 is, oh sorry, 2 times 2 is 4.
4 and then
I
4
already have
9s are 36.
4x. Now, what should be multiplied with 4x in order to get 36?
9.
9. Excellent. So basically, b is going to be 9 plus I have b squared, so which is 9 in this case. Whatever number I write here, I'm going to write it down here because they both have b. So this is going to be 9 square. Okay, now I'm going to check if anything has changed by mistake in the question. Now, 2x whole squared is actually same as 4x squared. So I'm good over here. Okay, now the next one, 2 times 2x is 4x, and then times it with 9, you get 36x, which is actually equal to 36x. So it doesn't make any difference. So we are good here as well. All right, now the last one is 9 square. Now 9 square is 81, which is exactly same over here. So I have actually transformed this whole thing into this particular format as 2x whole square plus 2x, 2 into 2x into 9 plus 9 square. Now I know a square plus 2ab plus b square is always equals to the factors a plus b whole square. Now what is a in this case?
2x.
Plus what is b in this case?
9.
9. There you go. Factorization done. Remember, not all the quadratic equations or expressions can be factorized completely by using a completing square method. Okay, so that is why this was a thing which I told you in the beginning. Whenever you get a question and the question says factorize, do not jump to the completing square method. First of all, go like right away, just choose, do not think of any other option. Just simply go for the middle term breaking method. But if the examiner bounds you that factorize this by using a completing square method, then definitely that particular question can be factorized by using a completing square method. Then you're good to go. And you are actually bound to use the completing square method. Okay? Then you don't have an option for the middle term breaking method. Got it? So this is how a completing square method works. I'm going to keep this right here, like this part of the screen right here, while I write down another question here for you to solve it. There you go. I want you to factorize this by using a completing square method. Come on. The same method. I'm keeping this part of the screen right here so that you can refer back to the question which I have done for you guys and check if there is any problem.
Sir, I've done.
Excellent. Let's just wait for the others. Done. Very good.
Done, sir.
Excellent. Iman, share your answer. Okay, anyone would like to share the answer? Asna,
Okay, I
Yes,
would
sir.
like to. 3x
3x,
minus 7 whole square.
3x minus 7 whole square. Excellent. I'm going to quickly do this for you, just for those who couldn't do it. So now this one clearly looks like it matches with the expanded form of the second identity because it has a negative sign in here. So what I'm going to do is I will write down the expanded form of the second identity down here as a model for me so that I don't make any mistake by chance. All right, now what I'm going to do here is transform the given expression according to this model. All right, now this is going to be, I'm going to choose a different pen. Okay, now the first one, 9 is a square of 3 and x squared is a square of x. So I can rewrite it down as 3x whole squared. I will clearly make sure that I do not change the values. Okay, now minus. Now I have 2 in the model, so definitely I can't get rid of it. So I have to put down 2 times a. A in this case is the one inside the square brackets, which is 3x. Now I need b. Now b should be set like 2 times 3 is 6. Now 6 times what is I don't intend to change the values of the question. Now I have 42 in the question. So I need to look for a number when multiplied I should get 42. So 6 times 7 is 42. So from there I know I should write down 7 here. Now this is b plus b square again. So b was 7 which we decided over here. So this should be 7 square. Now I'm going to check one more time. So 3x whole square is actually 9x squared. I'm good to go. 2 times 3 is 6. 6 times 7 is 42. I'm good to go. Plus the last part is 7 squared, which is actually equals to 49. So far so good. It looks perfectly fine to me. Now simply write it down in a factor form. So a square minus 2ab plus b square, we know the factor looks like a minus b whole square. Now a in this case is 3x and b is 7. That's it. You're done with the factorization by using a completing square method. Any questions over here? Any questions?
No,
Any
sir.
confusions? Okay, now this was factorizing by using a completing square method. Now, what it doesn't mean that completing square method can only be used for the factorization purpose. We can use the completing square method for specific types of question where the examiner wants you to wants you to rewrite the given equation or the given expression in a specific format. For example, x squared plus 16x plus 9. Now, this is a question here. Now, the examiner wants you to rewrite this down as x plus m whole square plus n. Now, we can rewrite this. Basically, examiners wants you to transform the given expression into this format. Now we know like this whole format is x plus m whole square plus n. We know a part of this format, which I'm highlighting here, can only be achieved by a completing square method. So I will start off with a completing square method and see where things go. Do not worry about the n outside. It means basically not everything will be inside a completing square. Like there will be few extra things, but remember the rule: do not change the values. Keep the balance of the equation or the expression. Okay. Now, this is the original expression, x squared plus 16x plus 9. Now, the examiner wants you to rewrite it down into this particular format or transform this into this particular format. Now, this one matches with the given expression matches with the first identity. So I'm going to write down the expanded form of the first identity just below that as a model so that I do not go wrong anywhere. Okay, so I will be transforming all of this into this particular format. All right, so let's just start. So the first one is just x squared, so I can rewrite it down as x whole square. Are we good up till here?
Yes, sir.
Okay,
Yes,
now
sir.
plus, okay, 2 from the model, and then a. What is a? You started off with a. What is a?
X.
Yeah, a is just x. Now you need b, but remember the rule, do not change the values. So 2 times 1 is 2, and 2 times what should be 16, because I do not want to change the value of the middle term. So this is basically the middle term we are dealing with for now. So 2 times what is 16? 8.
8.
Excellent. So this has to be 8 plus b square. What is b? We just dealt
8.
with b.
8.
8.
8. Excellent. Okay, now let's just check if there is anything changed. Okay, now the first one, x whole square, is actually same as x squared. It doesn't make any difference, right?
Yes, sir.
Okay, now look at this one. 2 times x times 8. This will give me 16x, which is same as this one. Good to go. The last part, 8 square, which is 64. Boom. Which is not 64, which should not be 64. What do we need here? It should be 9, isn't it?
Sir,
3. We
So
need a 3 over here.
3, yeah.
no, if you're saying that if I put 3 squared here, then this we should have 3 here. If I put 3 here, then 2 times 3 is 6x, which actually changed the question. So not buying that. We'll stick to this for now. Just I'm putting this in a I'm highlighting it so that forget about whatever you have done up till now. Just try to balance it. Okay, now do we have this in the question, x squared?
Yes, sir.
Yes, sir.
Do we have this in the question?
Yes.
Yes, sir.
Do we have this in the question?
No.
No, sir.
No. Okay, now another question.
Yes.
Do we need this?
No.
No.
I
No,
think
sir.
no, sir.
If I don't have 8 square, how will I be able to achieve the completing square format? It's just because of this 8 square that I am able to achieve this format in a complete form. I need this part, the completing, and this can be only achieved by a completing square method. So we do need this. Now the thing is, this is not in the question, but I need it. Okay, fine, no worries, you need it. I let it keep. So that is why I highlighted it. Highlighted means I'm locking it. But this is an extra thing. I have to pay for it. So I have to balance it. So what is this? Plus 8 squared. So in order to balance it, I'm going to put minus 8 whole square. Now if you check the balance overall, this is x squared, this is 16x. Technically, they will actually cancel out each other, which we are not going to do, but technically they will actually cancel out each other. So we have the balance maintained up till here, isn't it?
Yes, sir.
Okay,
Yes,
so
sir.
I'm just going to go a little bit back just to make it clear one more time, if just in case if it's getting confusing. Now, the first one is in the question, x squared, good. The second one, which is 16x, which is in the question, good. And the third one, six is 8 squared, which is equals to 64, which is not in the question. That's bad. But the thing is, unfortunately, I need this. This is not the part of the question though, but I need this so that I can complete the format. So what I'm going to do, I'm going to trade off. I need this. Now this is an extra thing here. It came from outside, so I need to maintain the balance. So I'm going to do the opposite of whatever I have done. So plus 8 square. So in order to balance it, I'm going to go for minus 8 square. Now if you check technically, plus 8 square minus 8 square, they will cancel out each other, but we're not going to cancel out. I'm just showing you that how is this balance, how bringing minus 8 square does not affect this, because by bringing minus 8 square, the whole equation is actually balanced up till here. Now what's missing? We had 9 in the question, which we don't see anywhere down here, so I'm just going to copy that down as it is. Got it? So these two will cancel out each other, which we are not going to cancel out, and this is also in the question. Now I'm just going to erase these ticks and the crosses and the highlighted part. All right, now the one written in red, that will be x plus m whole square. Basically, you need to complete the square. So this will be x plus 8 whole square minus, what is 8 square? 64, and then plus 9. You dissolve these two, x plus 8 whole square, and this will give you minus 55. Okay, is the format achieved? This one?
Sir, I'm confused.
Where?
Okay, I just got it.
Okay, now is this format achieved?
Sir, does the sign matter? Because in the format it says +9, but the answer that we got is minus. Does the sign matter?
Excellent. Yes, the sign matters. That's why I asked the question if the format has achieved. Okay, so I need a positive sign here. So can I rewrite it down as, does it make any difference? Does it make any difference?
Yes, sir.
No,
No.
no, sir.
Minus
No,
is
sir.
still minus. So I have actually transformed it. I haven't changed anything. So the examiner, now the format is achieved. Now, if the examiner asks you what is the value of m, so m here is 8 and n here is negative 55. Got it? I'll let you copy this down on your notebooks, then I'm going to give you a question for you to do it. Actually, I'll write down the question on the same page. Just a minute. X squared plus 4x minus 6. X squared plus 4x minus 6. The question was same. Actually, copy this down. I'm going to show you the same question on Cambridge past paper. And let me know once you have copied it down. Done?
Yes, sir. Done.
Done, sir.
All right, so there you go. This is a Cambridge question. Do not get confused with this part, like what is this? Forget about it. Just focus on the green highlighted part. X squared plus 4x minus 6, x plus m whole squared plus n. The thing I said do not get confused was specifically for grade 9 students. Grade 10 and 11, they shouldn't get confused with f of x. This is nothing new for them.
So, sir, we don't have to use fx. We just have to answer the
Grade
green
9
highlighted part.
students, grade 9 students focus on the green parts. Javeria, why do you ask to record the lesson? You attend the lesson, but why do you ask to record it? Javeria,
Yes, sir.
you attend the lessons regularly, but why do you ask to record it?
Actually, sir, I have a little bit internet connection problem these from past week. That's why.
Okay. This is the last time I'm recording the lesson. Next time onwards, no recordings. Okay? Even if I do record, I will not be posting them on the Google Classrooms. Done?
Yes, sir.
Okay, give me the value of m. Anyone from senior students, please? Done? I really want to get the answer from senior student this time. Anyone from 11s?
Sir, m is equal to 2.
Sorry, say again.
2.
The value of m is 2, and what about n?
Minus 2.
M is 2 and n is minus 2. Okay, let's just check now. I'm gonna redo this. Dua Rizar, you got minus 10 for the n. Okay, let's just check. Okay, now this one matches with the expanded form of the first algebraic identity. So I'm going to put the expanded form down here as a model. Okay, now I'll be transforming the given expression. The first one is x squared, so definitely I can rewrite that down as x whole square, which is same as this one, plus 2 times a, and then for the b, the b should be 2, because 2 times 2 would give me 4. So b has to be 2, plus 2 whole square. Now if I check question carefully, this is in the question, this is in the question 4x. 2 square is 4, which is not in the question. Okay, now this is not in the question, which definitely came from outside. So I will be trading off with its counterpart in order to maintain the balance. So now what's missing here? Minus 6 was in the question, which is not here. So I'm going to put minus 6 over here.
Mr.
Now,
Qasim?
Ji bache,
Yes, aren't we supposed to use the second identity, the one with the negative sign?
no, because if you use that, you will end up with a negative sign here, which will be 2 times 2 is 4x minus 4x, but in the question you have plus 4. So basically you have to focus on the first 2 terms of the given question.
Okay, sir.
Okay, all right, now a part of question, not part of questions, but balanced, a part of questions. We need this in order to complete the square, and this is extra, and it is balanced as well. So we are good to go for the next step. So x squared plus 2x into 2 plus 2 square is basically a square plus 2ab plus b square, which is always equals to a plus b whole square, which in this case is x plus 2 whole square. Now things I'm left with outside are basically minus 2 square is 4, and then minus 6. Now if I solve this further, which is going to be minus 10, and not solve actually, x plus 2 whole square, and then plus, and then a minus 10. There you go. The examiner asks you for the values of m and n. M is clearly 2 and n is negative 10. Clear? Everyone good? Now you can clearly see the question. The command word never said to factorize it. The examiner gave you a question. For grade 11 students, it should be very much clear now. All you have to do is put f of x behind these equality signs. This is just for grade 11 and grade 10 students. Grade 9 students don't have, they shouldn't worry about f of x for now. Okay, now the question was, this is the given function, and the examiner wants you to rewrite the given function into this particular format. And once you achieve this format, tell the values of m and n. So it's nowhere written that you have to use the completing square, but you just have to use your basic concepts and instincts, because this particular format, x plus m whole square, can only be achieved by using a completing square method. So see, we are not using completing square method just for the factorization purpose. We can use it for a specific, for this particular type of questions as well. Are we good? Any questions?
No, sir.
Yes.
Okay, in the next lesson, we shall proceed further.